Hello and welcome to another pre-lab video here for Chem 106. The purpose of this video is to do a little bit of prep work for you to help you get ready for the Group 3 qualitative analysis lab. So in this qualitative analysis, this is the Group 3 analysis. This is the last qualitative analysis that we're going to do before we get into the general unknown, which is your lab practical final exam at the end of the semester. What characterizes this group as being kind of unique and interesting is that we are dealing mostly with transition metals, aluminum being the one real exception to this. And what all of these have in common is that if we bring the pH up to a pretty basic level, and we will do that using ammonia, if we bring it up to a pretty basic level using that ammonia, what we will get is a series of hydroxides and ammonia complexes. And when we blast those complexes and those hydroxides with sulfide ion in the form of ammonium sulfide, what we will get is a series of ions here that are sulfides. So very similar to what we just did in the group 2 analysis where we were dealing with sulfides there. This time we are dealing with basic sulfides as opposed to acidic sulfides. And so the primary purpose of this experiment is really to kind of raise that pH up, get it to where it's really, really basic, form these sulfides, and from these sulfides, then we can start to split them off into a pair of subgroups and do some simple chemical testing on them. So if you're following along in the flow chart here, what you'll see is that we're doing this series of steps to create these solids, and then we are going to dissolve those solids and reconstitute them. And when we reconstitute them in this basic solution using hydrogen peroxide, one of two things happens. Either we get the formation of ions and complexes here, which will be separated on their own in a separate analysis, or we get these series of solids. And when we treat these solids with more peroxide and lower the pH using sulfuric acid, what we get are 4 ions that, interestingly enough, we do not have to separate them from each other because there are characterization tests that exist that will isolate each of them through the use of some kind of chemical agent that will usually, in most cases, form complexes that have very distinct colors when put in the proper combinations. And so one of them is the formation of the iron thiocyanate complex, that blood red complex. One of them is a cobalt thiocyanate complex, which is kind of I don't know, I guess somewhere between a kind of a seafoam green and a light blue kind of color. One will form a nickel ammonia complex that when reacting with DMG gives us this strawberry red kind of color. And the manganese, when reacting with bismuth, will form the permanganate ion. And you're familiar with the permanganate ion. We've worked with it a couple of different times. It gives a pinkish to purplish kind of color depending upon its concentration. On the other side, so those things that complexed and were in solution, when we treat them with acid, we can get them to separate into aluminum and chromium and zinc. And then with chromium, we can do testing on it to determine the chromium's presence. For that, we're going to use barium as opposed to lead, but it'll give us a very similar kind of test. And for the zinc side, adding hydrochloric acid will form a zinc ion, which we can then complex and create a compound with the potassium ferrocyanide here. And this gives kind of a grayish to greenish kind of color. where we have to be really careful about this one is that the solution itself kind of has this blue-green tint to it. And so we have to make sure that the solid actually carries that color as well. So procedurally speaking, we have this written in as a 2-day lab. And what we have to remember is, first of all, the notebook that you are using is completely blank. Just like you did with the group 2 analysis, you're going to have to create your own notebook. We're not doing that for you. But what you can see is that procedurally, the group here, we can do some separations here. So notice that procedure 1 and procedure 2A, these are listed as practical only steps. So for your analysis, in the group 3 analysis, you do not need to do these particular steps, because what these steps do is they help to separate and characterize the group 3 ions from anything that might be left over in your practical. So these 2 steps are really important in that scenario, because there are other things present. In the group 3 analysis that you're doing, it is only group 3 ions that are present. There are no contributing distractors. And so these are actually unnecessary steps. You'll actually begin with procedure 2B. And with this procedure 2B, this will actually shorten the procedure pretty considerably, because you can start directly with adding sodium hydroxide and peroxide, and using that to separate the nickel and the aluminum subgroups from each other. And then procedure 3 preps the nickel subgroup for those individual tests. And then procedures 4, 5, 6, and 7 are those individual tests. For procedure 8, you are taking the decantate from step 2B and treating it with nitric acid to acidify it, and following the steps to separate the aluminum from the chromium and zinc. And then if you follow the rest of procedure 8, you'll actually characterize the aluminum and determine its presence. And for chromium and zinc, you'll be looking at procedure 9 here, where you can specifically test for those individually based on your individual results. So in terms of time, the group 3 analysis, even though there are more ions, it does not take as long to do. And the reason it doesn't take as long to do is, 1, we get to skip the 2 most time-consuming steps. And 2, we get to, we don't have to separate all of the ions from each other before we characterize them, because the ions themselves, once we get them into their subgroups, the ions themselves have specific enough tests associated with them that we don't have to worry about, okay, well, first I need to take this and completely separate it, then characterize it. And then I need to take this next one and completely separate it and characterize it. Once I got those 2 subgroups established, for the first subgroup, the manganese containing subgroup, that one, straightforward, bang, 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 you go through. And then for the zinc and aluminum subgroup, you have to separate the aluminum from the rest, but then you can test the aluminum on its own, the chromium and zinc on their own. So your goal for day 1 is to go through the known analysis completely. Your goal for day 2 is to go through the unknown analysis completely. So that is ultimately what you're doing. That's what you're expected to do for this particular lab. And so I would encourage you, read through the procedures a little bit more finely than I just walked through here. And make sure that when you get into that pre-lab, there is another pre-lab video that covers this material more explicitly and helps you to answer these questions here. But for now, that's all I really wanted to do, is just kind